I'm Harish Agastya with Trend Micro. I'm with the data center security business inside the company, and I have with me Bob Dupuy from Concordant, and we'll be talking about new security paradigms in protecting private cloud environments today. I'll start off just with a slide or two, and then I'll hand it over to Bob to run us through specifically the Beth Israel deployment that Bob's been driving. So we'll talk about the BitPo Cloud today and BitPo Cloud tomorrow, and then we'll try to glean some lessons learned from that experience. So try to summarize, recap that for the benefit of everyone. So typically, and you may have seen this slide more than once at VMworld. If you've certainly, those sessions that I've been in, this slide from VMware has come up quite a bit. It's the VMware virtualization journey as they paint it, right? Organizations go through several stages in their virtualization experience when they move from physical to virtual. Initially, they start off with a whole bunch of physical servers in their data center. They start virtualizing their low-hanging fruit first, their file servers, web servers, print servers, and the like. And they realize benefits in terms of cost efficiencies from that experience. And they ramp up in terms of the level of virtualization by virtualizing some of their more mission-critical servers, desktops, and the like. And they get increased cost efficiencies. In addition to that, they get quality of service improvements too, as they start adopting higher-level virtualization technologies such as fault tolerance or DRS and the like. And then finally, in stage 3, organizations start moving to the cloud. That might be the private cloud or public cloud. And then the benefits are, again, increased cost efficiencies and quality of service, but also now your business is a whole lot more agile, right? Traditionally, organizations move from left and try to move more and more to the right by going from stage 1 to stage 2 and eventually to stage 3. We're going to be talking about an organization here today that directly leaps straight to stage 3 in their particular project. So with that, let me hand it over to Bob, who can run us through his experience there.
Thank you, Harish. As Harish said, my name is Bob Dupuy. I work for Concordant. Concordant's a healthcare information technology services firm. We specialize in the planning, design, implementation, and management of ambulatory electronic health record solutions. And what we're going to talk a little bit about today is an EHR solution that we worked on and developed in conjunction with Trend Micro, VMware, and the client to build a multi-tenant private cloud architecture to deliver electronic medical records to the affiliated physicians for Beth Israel Deaconess Physicians Organization. Beth Israel Deaconess Physicians Organization is basically the aggregation of physicians associated with Beth Israel Deaconess Medical Center in Boston. It's a fairly large medical center. Servicing, they have about 1,500 member providers throughout eastern Massachusetts. Their goal of their EMR program initially is to promote and improve the quality of care for all patients. That's the goal of every EMR program. That's basically the holy grail of EMR and why we're all doing it today. A little bit of background on electronic medical records. How many folks here work within the healthcare industry? Wow, that's cool. All right. So pretty much everyone in here is very well aware of the fact that there's a major drive to the implementation of electronic medical records across the United States. The goal of that being always to improve the quality of care, but the real goal, as we all know, is probably to reduce the cost of health care. We all know, or hopefully we know, the billions of dollars being pumped into the implementation of EMRs across the United States as part of the American Recovery and Reinvestment Act, or the stimulus package, something we can debate the effectiveness of later on. So, this is really something that's being pushed. It's being pushed along. It's not an easy thing to do because of some of the challenges we'll go through. The BitPo EMR program has been around for 3+ years. So we have some interesting lessons learned that we like to share today, and we share across that can help make EMR actually possible without making it too costly. So a little bit more about BitPo and some of the delivery challenges of electronic medical records. Specifically for BitPo, we're talking about remote, geographically dispersed small business organizations that are being pushed into a single application to do their business. These are not owned organizations. They're independent businesses. They run their own practice. They run as an independent organization. They're part of a contracting organization, and now they're being pushed this application, this EMR, to do their business, but it's still their business. And the other challenge, of course, is that geographic dispersedness. It's a huge challenge for services, support, security, and implementation. That's one of the real major challenges. The second one, especially for BibPo, was that this solution, it needs to be very scalable and very modular. It needs to support growth. One of the major challenges of this program was that you can't force these organizations to join the program at a specific time. So we needed to be able to take a small architecture that could grow easily and seamlessly without huge cost because of those scalability and modularity requirements. What you're going to see as we move forward is not only did we have that, but this thing really changed quickly as we move forward and continues to change, where we're adding scope, scale, and different services that we needed to add quickly, easily, and securely. With the large group of folks here that are part of the healthcare industry, I'm sure that you know that physicians do not tolerate downtime. They don't tolerate any reduction in performance. And the perception of reduction in performance is an interesting one with physicians. It's not like you or I, or it's not like someone within the banking industry in the HR department who says, oh, this thing's running slow today. When a physician feels like it's running slow, he clicks the same link 1,700 times and makes it worse, then calls and screams and yells. So this thing had to be reliable, redundant, and be highly available, but not drive the cost through the roof in order to get there because there wasn't a huge budget for this. The big one in the room, the big one always in the room for any healthcare implementation is cost. This thing couldn't cost $1 bazillion. We couldn't create, multiple hot sites. We couldn't make everything, clustered environment. We couldn't, the physicians' organizations, the practices themselves, aren't buying T1s to connect to this thing. The cost drivers in healthcare are incredible, and this was no different. And then the final thing is it needs to be easily manageable. So what do we do to address those challenges? Well, basically what we ended up doing was architecting a multi-tenant private cloud architecture. That was the solution we ended up with. Of course, 3.5 years ago, as we were building this thing and we created the design, we had no idea we were building a multi-tenant private cloud architecture. We just knew we had a solution that we needed to create, and we found some products and some architectures that could do that. And then about 1.5, 2 years later, someone came to us and said, hey, you guys built a great private cloud. Do you want to present on it? I said, we built what? Oh, we built, yeah, that's exactly what we did. We built a multi-tenant private cloud. That's where we were going. Sure it was. So the promise of cloud computing basically is a little bit of a misnomer where we're coming, but what the promise of our architecture was we could provide increased EHR access very simply and easily that would drive and improve the quality of care. It would be very mobile, something that could flex up and scale up to provide access to external physicians and patients in the future. It gave us significant cost savings where we were able to get a very highly available environment pretty cheaply as we move forward with our architecture. And the biggest thing we got out of this is it became very scalable and modular. And as you'll see, this thing did scale up pretty quickly, and it's continuing to scale up. And the architecture we chose and the architecture we ended up with VMware and Trend Micro really, really, really enables that. Without it, this thing would have been dead in the water. So we're here at VMworld, so clearly our private cloud is a VMware-based private cloud. That's kind of obvious. I wouldn't be sitting here talking about something else probably, right? So basically we took the VMware product architecture, the Trend Micro security services and set, and Concordance Healthcare Information Technology Services to really build a secure, robust, and cost-effective EHR infrastructure. One of the key components of this infrastructure, and one of the key requirements of the program was it needed to be delivered via the internet. The application isn't a browser-based application, but as we were developing this, they had just released an SSL-enabled client, and the executive team at Beth Israel Deaconess Physicians Organization really wanted to make sure that this thing would be delivered over the internet. What we didn't want to do is manage a bunch of VPN tunnels and deal with all the wonderful headaches of that over DSL connections and over cable connections. And I think we all know that was just a nightmare waiting to happen. The operational costs would have went through the roof. The reliability would have went down. So we really wanted to deliver this via the internet. However, we're talking about an application that just released an SSL version. And so basically we were taking an application that had never really been opened up to the internet and opening it up basically to the internet for these physicians to access via basically web-based protocols. So there was some significant risk we saw there. And to address that risk, you'll see, the Trend Micro tool set really enabled the program. Without it, it would have been dead in the water again. So VMware made it possible, certainly. We always talk about, one of the stories of VMware in the data centers is the significant cost savings that it can enable. And you hear about it, but you don't necessarily always see real hard number savings. And in this case, they were significant. The first piece is our overall initial design to get to the high availability we needed. We saved $100,000 by going with the VMware solution. The second big, and the real major one, and the one that, again, put the program at risk, was there was a little bit of a misunderstanding with our EMR vendor as far as what our requirements were for numbers of physicians, the requirements per server, how many physicians could fit on a server, what the memory requirements were, what the processor requirements were for each application server, for each database server. There was a misunderstanding, and they came back and significantly changed the specifications and the requirements for resources for each of the servers within the environment. What happened there is basically if we didn't have the architecture we had built initially, it would have cost about $300,000 to address that specification change. And again, everyone here works in healthcare. Working in healthcare IT, you know that a budget change of $300,000 in a healthcare information technology project effectively either kills it or gets people fired, or both, usually both. So in this case, we not only saved a bunch of money, but probably saved a couple of jobs, including my own probably, so there you go. So that was a real significant cost savings. The other one, ongoing costs, we've reduced our physical space, so we've reduced by 50% our monthly colocation costs. Our initial cloud was built on VMware Infrastructure 3. It's ESX 3.5. It still is. I know everyone's sitting here saying, this is VMworld 2010. What are you doing talking about old technology? I think you'll see as we move forward, we're moving forward into the new technology, into vSphere, into some of the new technologies that Harish is going to present that really, as we've changed the environment, these things are very much required for us to be successful moving forward. So those were some of the other challenges. Now, what about the security challenges? Clearly, we're putting a young application on the internet. And then not only that, but we're putting a bunch of health records on the internet here. There's a lot of statistics out there that healthcare is basically the number one vertical and growing for external criminal hacker attacks to gain information, to personally identifiable information. Frankly, I don't think they really care about whether you had a wart on your foot. They're looking for your personal information. At some point, I think that'll grow into some healthcare fraud, but at this point, it's more, there's a confidentiality issue with PII. Second, we faced a lot of risk in a multi-tenant architecture. We needed to make sure these things were segmented off. These are individual businesses. They're the owners of this information. They're the owners of the data, so we needed to prevent inter-VM attacks. We need to have instant-on protection when we brought up a new VM in this environment, since it was exposed to the internet in some manners. We need to make sure any VM we brought up was instantly protected. And our perimeter was basically no perimeter at all. We're pointing these things out to these small businesses that can come into the environment. So there's significant risk there. As you're going to see as we grow the environment and increase the scale and complexity of the environment, we get a lot of operational challenges and performance-based challenges. We can't grow the environment and impact performance. We can't add new services. We can't expand the environment, but impact the performance of practice A by adding practices B, C, and D. So, we have to deal with, as the environment grows, antivirus updates across the environment. How's that going to impact all the practices? We can't degrade performance. You just can't. Physicians get really peeved when you do that. And we had some significant operational and administrative burdens, which complexity of an environment can certainly add to the security risk and exposure to the environment. And finally, we have compliance requirements. We've always had HIPAA, but HIPAA's changed. We have the high-tech changes that are also part of the stimulus package that do a couple of things. They require breach notification, so you really need to see who's accessing what when and be able to audit that quickly and report on that quickly. And there's also going to be more enforcement of HIPAA and larger fines. So, making sure you are absolutely, no kidding, HIPAA compliant is a requirement moving forward. And meaningful use. How many people are familiar with meaningful use for EMRs? That basically says, in order to meet the meaningful use requirements, get your $44,000 per physician in an ambulatory environment, you have to perform a risk assessment and then address the findings of that risk assessment to make your environment secure. So those are all of the things we face from an EHR security challenges perspective. And in this case, Trend Micro really did keep it secure. I give the example, how many people have been a part of an external application security assessment on an application and seen the results from that? So just about any application out there has vulnerabilities in the application. I don't care what application it is, there's vulnerabilities in the application. I worked at one of the larger banks in the country. I worked on their online banking solution as they were moving to multi-factor authentication. And this is a very large bank. This is their online banking solution. This thing has to be airtight, secure. When we did the application security assessment, lo and behold, there were absolutely vulnerabilities that had to be addressed within the core code. SQL injections, cross-site scripting, any number of typical things you're going to find in any application. Well, one of the first things we did in this case was do an application security assessment on the environment to figure out what we were facing as we were going to let this thing open up the floodgates and open this thing up to the quote-unquote internet for these physician practices to access. Trend Micro came in and did that application security assessment, and we had, let's just say, a fairly large number of application-based vulnerabilities that we would have exposed ourselves to should we have put this thing on the internet without doing that security test. This would have, again, killed the program. This was going to put a stop to everything. Trend Micro came in with their deep security tool set, applied that. We did the same exact test, same exact set of application tests, and we ended up with one vulnerability in the application. So basically, Trend Micro, the deep security tool set, enabled us to put this EMR out on the internet in a timely fashion within the program parameters, reduce our attack surface, so to speak, while enabling us the time to go back to the application vendor and say, you got to fix these things. Fix this one that we can't address, and go back and work on fixing the other 40. In the meantime, the program can move forward. We didn't put it to a screeching halt and cost a bunch more money. So really, that deep security tool, without it, we were dead in the water. It provides us with attack detection and prevention on the IDS and IPS side, and web application protection. It provides one of the interesting things we found that we get out of it is the ability to sort of patch an environment. So we address the vulnerability that a patch addresses, and then we can take our time testing and patching the environment before, so we're not patching too quickly for a 0-day. It's already patched by the Trend Micro tool. We can work through our testing process so we don't impact the environment with a patch. And as we've moved forward, we talked about some of those HIPAA requirements. We're looking at implementing integrity monitoring and log inspection to deal with audit requirements, et cetera. And it's part of a multi-layer security protocol, including the Trend Anti-X products across the server environment. And as you'll see, as the environment scales up and grows, that's going to become an issue for us. So a couple of key takeaways from this particular slide. This is really kind of a very simple view of the environment today, but the key takeaways and the reason for it is because I want to juxtapose this against the future state that's coming up. So you'll see how significantly things have changed. One is we're really talking about one constituency set that's accessing the environment, the practice office. Down here we have some external systems. That's basically, orders and results exchanged with lab environments. No big deal there. The other key takeaway here is our Trend Micro agents for deep security and antivirus are on each of the guest operating systems. And then the final takeaway here is just kind of scope and scale of the environment. It's not that big. This is pretty simple. This is manageable. This is something any of us can deal with. It's not huge. The volume of systems is not huge. The complexity of the environment is not huge. Not that big of a deal, right? So the key here is going to be to juxtapose this against our future state. And you're going to see, down here you're going to see a lot more stuff. Over here you're going to see a lot more stuff. And all through here you'll see a lot more stuff as we've kind of grown the environment. So what are the next steps to expand it? So we're talking about an expansion of scope, services, and requirements that are impacting the environment and require us to make some changes to the architecture as well as applying new better tool sets to secure it and make it more operationally efficient. One is where the initial scope of the environment was about 173 practices, the majority of them 1 to 2 providers. Small practices have small requirements. Larger practices, we found, especially with the application we chose, that larger practices have much bigger requirements. We have more resource requirements for larger practices, application set and database set. We have additional reporting requirements for those larger practices, et cetera. Second of all, they're adding practices. The program's successful, so we're adding more practices than was initially scoped and designed. I think the expansion of services is really the one that's is having the biggest impact, though. The two big areas here are the health information exchange and the portal process. As the program's grown, we've gone from basically just providing EMR services at the practice level. Well, what's the logical next step? To be able to take that data and make use of it, be able to exchange it outside the organization, be able to provide real value to the patient community through some portals. So we're adding a lot of HIE interconnectivity services here, where we're interconnecting with additional hospitals in the area. We're interconnecting with the state information exchange, interconnecting with the New England Information Exchange, and various other regional exchanges to really get some value out of exchanging data, so that you go here, your information's here, you go here, your information's here, and that's going to improve the quality and safety of giving care. The portal piece is, one, it's a requirement for meaningful use, being able to provide a patient portal. Two, it's just good business. Healthcare is a pretty competitive market. If you can provide a good patient portal, a two-way portal, both on the physician and patient side, you're going to attract A, more patients, and B, in the state of Massachusetts, one of the big things is to be able to recruit physicians. There's a recruiting war basically in eastern Massachusetts for physicians. It's pretty interesting. So a lot of these services are tools that BidPo uses to help recruit those services. A couple other ones, we have some advanced reporting. Now that we have all this data, we want to really get some value out of it. So there's some advanced Cognos-based reporting solutions that we're implementing, as well as some browser-based remote access, so taking the application that isn't browser-based and making a browser-based remote access solution. I touched a little bit on the increasing security requirements that are driving a lot of changes as well. So what are we doing? What is the impact of this expansion? Well, from our initial design here, we've basically more than doubled, or we are more than doubling the scope and scale of the environment. So we're going from 10 servers, 10 physical boxes and 61 virtual to 19 and 130 virtual servers. Nice. There's a slip. And I assume a lot of you are going, well, that's not a whole lot of virtuals per physical. Well, that's driven by the requirements of the application vendor. We're also adding significant risk through added exposure. We're adding huge amount of more users to access the environment. They're internet-based portals. Again, PII's up there. Again, health information's up there. So we're really expanding the scope and scale of what we're presenting out to different constituencies via the internet. Obviously, operational complexity and cost. We have more servers. We have more antivirus updates. We have more patches. So the environment growing has required us to spend a lot more time and effort and energy on operations. In the meantime, trying to make sure that those operations and those types of updates and requirements don't impact performance. You can't impact performance. I'm beating that one to death, but it's everyone who works in healthcare knows, physicians, it's can't do it. Significant increase in volumes and type of users, hit on that. We're adding external constituencies and increased system requirements. The EMR software market is an interesting market. Organizations are growing incredibly. There's one organization that over 4 years grew 460%. In addition to that, we're seeing a lot of consolidation in the industry, where an organization like Allscripts bought Misys, then bought Eclipsys. So, they're constantly adding more services to these EMRs, and that's increasing our requirements significantly for resources. So how do we address that? So how are we addressing those changes? We're doing it really in two. The top two are absolutely how we're doing it. The third one being something I see as really an enabler for getting EMRs out there to the environment in a cost-effective and secure manner. But through our upgrade to vSphere, we're going to be able to put more servers on more physical boxes, reducing some of our requirements. And with the vSphere upgrade, we get VMsafe and the vShield endpoint. That's really going to enhance our capabilities to secure the environment without impacting performance. And that's really something Harish is going to go through. The expansion of the Trend Micro Deep Security tool set. We're talking about agentless deep packet inspection. Harish is really going to talk you through a lot of what that means and how that works, where that's going to address our requirements to have an agent on every box. That's going to address our requirements for, hey, when we bring up a VM, it's going to be secured. We're going to be sure it's secured. It's going to provide us improved scalability through that process. And then enhanced logging and monitoring, where we're going to be implementing the log aggregation and file integrity monitoring tool sets that is part of the deep security tool set. That's going to allow us to do some pseudo change controls through checking what got changed and when, as well as being able to report on who accessed what when internally and externally. And then agentless AV, we're going to see significant impact there, where we'll be able to update and scan the servers within the environment, not on the guest OS themselves, but with basically what amounts to a virtual appliance. The third one, I really see VDI personally as one of the things that's really going to get us over the hump for implementing electronic medical records. For me, one of the biggest risk points is the endpoint at the physician's practice. And whoever's back there working on that endpoint, making bad decisions through their personal email and things like of that nature, you don't have a lot of control over it. So that's the most significant risk in it, is the endpoint. The second is the cost. One of the major cost areas is the actual implementation of infrastructure at the practice, right? You got to go out there, figure out what they have, implement a new network, implement, more than likely, because they've never invested in technology, implement new desktops, new tablets, new laptops, et cetera. There's a significant cost not only in services but in hardware there. VMware View can help us get rid of that, and it'll also make that environment manageable so we don't have to send somebody out there on a service call whenever something goes wrong. So remember, this was our first picture here, and let's see how we're, based on all of those, the impact, how this thing's going to change. One, we're going to have an external production environment. That's going to be our portal and HIE-based environment. So that's new internet-facing stuff with new constituencies accessing it. The second takeaway is down here. We've added a whole bunch of new constituencies: the external providers, patients, this mass quality data warehouse. So this is part of our information exchange. So this is the impact of adding a whole bunch of new people. Thirdly, you'll see one of the major differences here is before. We have, say we have the full 130 servers in here, we would have had an agent on every server. That's very difficult to manage, A. B, it can have a significant impact on performance. So with the new technologies, both with vSphere 4 and Trim Micro, we're going to basically have we're going to reduce the number of agents by half at least and increase our performance. So, if you juxtapose this against the environment before, you'll see the scale, huge. The services, we've added quite a bit. And basically, we wouldn't probably be able to do that unless we kind of made the jump to vSphere 4 and the new Trim Micro products. So with that, I'm going to hand it back to Harish to really go into some of the new technologies within VMware that are going to enable us to get where we need to go.
Thank you, Bob. So a quick... let's recap some of the specific actions that Beth Israel has undertaken in terms of their cloud implementation, and hopefully everyone on the team can benefit from that type of experience. Also, I want to touch on some of the technologies that Bob talked about and what we are working with VMware are announcing. Actually, the announcement went out today in terms of the agentless technologies. So firstly, we looked at the VMware virtualization journey, right? As organizations move from left to right, they get increasing benefits in many ways. Now, what often happens in that journey from left to right is security tends to become an obstacle in implementing that transition from left to right. Starting over in stage one, there are a few issues that you need to think about. Inter-VM visibility, a network-based, perimeter-based security device can't quite see traffic going from VM to VM. Those types of issues are small issues on stage one. But as organizations start moving from left to right, more and more security obstacles start adding up, right? You have not just the inner VM visibility issue, you have instant on gaps. I think Bob already talked about that. You have resource contention issues like AV storms when you have multiple concurrent operations all hitting the VM at the same time. You have a diminished perimeter. You're out there in a public private cloud environment. And you have multi-tenancy as well, and some of those issues Bob already talked about, right? So as you go from left to right, as you go past your various stages of virtualization out there into the cloud, security becomes an increasingly larger obstacle in enabling you to get there. And the ramifications of that are evident, right? When Gartner did their survey around what are one of the most common inhibitors to organizations deploying applications in the cloud, well, number one of that was security. So that's evident, and these are some of the reasons why. Now, in terms of having to deal with that, rather than have security kind of be an afterthought, as Bob explained in the concurrent Beth Israel study, in their project, security was part of the decision-making process right up front, right, in order to help them enable that project to even happen. So some of the lessons here that I try to cull from the Beth Israel Deaconess project. First of those is it is insufficient to secure applications in the private cloud the standard way that you would have secured them on a physical server inside the data center. Right? The old approach was to put something in the perimeter, network-based security, a firewall and an IDS IPS, and then something else on the host or in the guest, which was most commonly an antivirus type of application. That model simply won't cut it when you're faced in this private cloud environment, you have attacks potentially coming in from web applications, leveraging techniques such as SQL injection attacks, cross-site scripting attacks, etc. In fact, Verizon puts out a data breach investigations report annually. In 2009, their report basically said that 4 out of 5 records that were breached per that study came in using web application attacks, SQL injection, cross-site scripting, etc. In their 2010 version of the same report, that number went from 79%, which is 4 out of 5, to 90%, right? So it's an increasingly more common vector, something that just having your vanilla antivirus on the host and something on the perimeter, which in the case of a private cloud doesn't even apply, that's not going to help you. So it's important to supplement your security, your existing AV security, with other additional securities on these systems that you're putting out there in the private cloud or public cloud. So supplement it with additional protection, and that can be IDS IPS, firewall, web application protection. That's really critical, and as Bob pointed out, that was one of the key investments they did as part of their private cloud deployment. Additional technologies that might also be important and relevant is integrity monitoring and log management type of technologies, in order to, if you have compliance regulations in the healthcare arena like HIPAA, like high-tech, that type of capability where you are able to ensure that if ever there is a change to a critical system file, that you are able to track that and then prove that that is being tracked at a later point in time if the auditors were to ask. So those types of technologies are also very relevant and critical in terms of this deployment. So lesson number 1, beef up those server defenses beyond your traditional vanilla physical server defenses. Lesson number 2 is leverage some of the new security paradigms that are coming out. VMware had an announcement today around vShield Endpoint, which is a new set of APIs and completely complementary to a different set of APIs they announced at the last VMworld, known as VMsafe. How many folks in the room are familiar with VMsafe as a technology? Okay, a few hands up. VMsafe is a set of APIs that allows a virtual appliance sitting outside as one appliance on a given host to protect all of the other VMs on the host. No need for an agent within those VMs. And that is something that VMsafe allows us, Trend Micro, and any other security vendor that chooses to integrate those APIs to provide agentless firewall, agentless IDS, IPS, agentless web application protection. The new set of APIs that VMware has announced today also extends that type of virtual agentless protection to now have anti-malware technology protection also delivered in an agentless manner. So those types of APIs allow you to significantly continue to provide the same sort of protection that I'm talking about, that you, in terms of beefing up those servers, but at a far more manageable level, because you don't have a footprint on these other VMs. You can do all of that in an agentless manner from the outside. You also get better tamper-proofing from this, because you don't have the common dependency that has existed in the anti-malware industry ever since the industry was created for 20 years. You've always had to protect a system by having an agent on that very same system. And sophisticated pieces of malware today are able to defeat that. Because they're operating at the same level of privilege as the anti-malware, they can just go ahead and uninstall it, delete it, somehow subvert it, right? And this finally allows the security industry to kind of break free from that type of dependency. So another additional advantage to these types of APIs that are now starting to emerge, right? VMware has kind of been the leader here in the space, trying to innovate in terms of coming out with these new delivery mechanisms for providing security in virtual environments, in cloud environments. This is a little bit more technical detail around how that type of APIs, the VM-safe API specifically, allows us to provide IDS-IPS deep packet inspection from outside. So I won't go into great length here, but suffice it to say that this is the virtual appliance here. Half of the IDS-IPS or deep packet inspection actually is performed inside the hypervisor, leveraging a driver, a fastpath driver. So we're able to do basic packet inspection to determine if it's a bad packet, immediately drop it. And if it passes that, then much of the computation actually happens within the security virtual appliance itself, in terms of making sure that this packet is truly not exploiting a vulnerability that exists in the application, leveraging, in our case, Trend Micro's rule sets that have been defined to identify common vulnerabilities, known vulnerabilities that are in the space. Right? So the other message here I wanted to say, if you notice, none of the other VMs here have any agents on them. So we are able to provide deep packet inspection from the outside, leveraging these APIs. The VM-safe APIs were part of the VMware vSphere 4.0 offering, which came out over a year ago. Yes, please.
How does that work with the distributed switch? Is that appliance per host, or is it?
It is one per host. That's correct.
On a distributed switch, how would you still have to have one for that networking those distributed across multiple hosts? You have to have one for each.
You will still need one appliance per host. Correct. And so these APIs were available as part of vSphere already. It allowed us to have enough packet level information to perform deep packet inspection from the outside. Now, in terms of, Trend Micro has been one of our secret sauces is the threat protection in terms of an anti-malware perspective, signature scanning. Right? Those APIs, the VM-safe APIs, which we integrated, the VM-safe network APIs, in order to provide IDS-IPS over an appliance, we were not able to leverage those APIs to provide full agentless anti-malware services, because we need information at the file level in order to be able to perform that. vShield Endpoint gives us that. Right? It was announced today. VMware is making that generally available in a few weeks from now. In fact, Trend Micro is concurrently making a product enhancement to the deep security offering to leverage those APIs and deliver agentless anti-malware as well, which Concordant and Beth Israel are looking to implement in their next phase of their deployment. The vShield Endpoint APIs allows us to, rather than have agents for anti-malware within each and every one of these systems, now provide the anti-malware capability from outside, right? And I have a little bit more depth on this, because every time in our booth where we demoed this, we've had tremendous interest. So I added a few more detailed slides around how we're able to implement the agentless anti-malware capability for everyone's benefit. But the value proposition is this. Rather than have to put an agent on each one of these systems and download patterns on there, all of this can happen agentlessly via the virtual appliance, which means significantly improved manageability. Right? No need to provision an agent on each and every one of these VMs. No need to reconfigure it over time. No need to patch it as patches become available. and no need to download patterns multiple times a day to each and every one of those VMs anymore. Now, all of that, there is one single pattern that needs to go to the virtual appliance, and even that in the Trend Micro case leverages what we call the smart protection network, allows us to have part of the patterns reside in the cloud, and the rest of the pattern is a much smaller, lighter pattern that sits in the appliance. Right? We get faster performance because one of the challenges, as Bob talked about, is antivirus storms, where you have resource contention happen when a bunch of physicians all come in on the system at the same time, and the system starts scanning at the same time. That causes performance degradation because the underlying infrastructure is one and the same. So significant performance-intensive operations, if they were to happen concurrently, tend to bog down the system. Right? And as physicians are not, like anyone else, will not be prepared to deal with that type of disruption, you get freedom from those types of storms because the appliance is the only one that's performing the anti-malware operations. It's able to adequately serialize, ensure that you don't have concurrent operations like that hitting your storage devices. You have stronger security because the instant a VM is on, we know about it because it's tightly integrated with the VMware vCenter infrastructure and can auto-protect a new VM as soon as it's ready, as opposed to the old model where a human had to go in and install an agent on there, or even if the agent was in the template, had to go into the security console and configure it so that it's ready to go. Right? You don't have that type of dependency. It's automatic. And even not just with new VMs, but also offline VMs that are reactivated, right? Instantly, as soon as it's ready to go. In the old model, it wasn't ready to go because its understanding of good or bad was out of date. You don't have that type of challenge anymore. Right? And ultimately, the value is, right, in terms of ROI, as Bob was talking about, he can now put more VMs within that private cloud deployment than he could before, right? Because you're freeing your infrastructure from having to do redundant work and having to do contentious work with other VMs. So we're leveraging a lot of color on that slide, so apologies for that. But the goal here was to just highlight to you how this thing works. I have an entire session dedicated to this tomorrow at, I think, 1:30, so I won't delve into this in detail. Folks have any questions, please feel free to meet me afterwards. But we're essentially doing everything that is performed in a typical antivirus operation, including on-access scans, which happens anytime a file is opened. You read or write immediately that, a physician opens up a document, that a scan kicks off. That's a very lightweight scan performed within the appliance. The other one's an on-demand scan. When it's a scheduled scan happens, where you scan the entire disk. All of that activity is performed within the appliance, including remediation. And then there's some caching capabilities in there to optimize performance. The results of that are clear. When we did some early stage testing here, we have some clear benefits. Now, I haven't put a y-axis numbers here because I specifically didn't want to do that until we have actual independent benchmark results published. But we did some internal testing, comparing it against 3 other antivirus solutions in the market, and I've got blue, yellow, and red, and you can try to interpret who they might be. But we compared that against the performance of the deep security virtual appliance, and the benefits are clear. Where in the case of any of the typical market AV solutions, where memory consumption grows linearly over time, because you have to put an agent on each one of these VMs. Commonly, they consume 100 to 200 megabytes per image. The memory consumption requirements for the typical solution grows as you put more and more VMs, especially if you are implementing VMware View, where you may have 60 VMs per disk, per host. You have a significantly larger consumption. In the case of this type of model, where we're leveraging the vShield endpoint APIs, we're able to essentially keep that flat. There is not much growth in terms of requirements because you have one appliance securing that entire environment. We also have benefits in terms of signature update times and bandwidth consumption. So when we did a study against 10 agents and how long it would take a pattern to update, with the common solutions in the market, it takes a fair amount of time, and you can cut that down to about a tenth. Right? That was for 10 agents. Now, in VDI deployments, you'll have much more than that. You can factor in the time savings as well as the bandwidth savings. Right? How much consumption, how many gigabytes per second are you consuming in terms of doing those pattern updates? If you had just 10 agents per machine with the common solutions, instead compare that with the vShield-enabled agentless technology. Right? This is about at least about 1/10, if not better, in terms of benefit. So just to close here now, we've been Trend Micro has been in this virtualization and cloud computing security space now. We've been investing heavily over the last several years, working very closely with VMware. We are one of VMware's tightest partners in terms of providing security specially designed for VMware environments. And the mantra and the goal of both companies is to provide better than physical security. Right? That's one of what we think we've been working towards in terms of integrating these APIs to offer. Right. Just to close now again, Trend Micro Deep Security, we have multiple technologies within the deep security offering. As Bob pointed out, they're leveraging all of these minus the AV piece, which we've just added, which I think they're looking at in terms of the next phase of the BitPro project. The product secures both physical and virtual because as common deployments go, everybody isn't at 100% virtualization. So it's important to have one solution, whichever one you pick, that provides security within the physical servers that you have and the virtual servers within your data center, but also seamlessly extends to the cloud as well and protects that environment too, right? And the deep security product that we have provides just that. We have a virtual appliance that provides agentless anti-malware, IDS, IPS, firewall, and web application all in one appliance. And then in addition to that, we have agent-based technology as well, so that if you did want to, you can choose to put agents on select VMs. And you might want to do that in some special cases, especially if you have a VDI deployment and you have offline desktops. When the desktop checks out and goes out beyond the scope of influence of the virtual appliance, then the agent can protect that particular VM. Or maybe for defense in depth or performance reasons, scalability reasons, you might want to put some resource hog VMs and have agents on those as well, right? So, and there is coordination between the virtual appliance and the agent, where if the agent were to disappear, the virtual appliance will step in and protect it, right? So that's additional defense in depth over there. So that was the presentation. Now, we do have a demo at the Trend Micro booth where we do demo this technology, and these are some links for you to go if you want additional information. I'd like to now open it up to the floor if you have any questions for either Bob or I. Please.
With the vShield virtual appliance solution, how do you keep it from like a download service and look at that one virtual appliance where you get knocked out?
So it is a hardened lockdown appliance that we have, and you can protect that particular virtual appliance. You can set it up with a backup. You can have it in terms of using Affinity. If ever you wanted to that virtual appliance were to go down, we don't believe it. We think it's more resilient because of the fact that it's hardened as opposed to the agent, which is much more at risk of tampering. But at the same time, you can provide added defense by setting up Affinity so that if that appliance were to go down, you would be able to move your VMs off of to another server that did have a virtual appliance on there.
Sure. What are our performance targets and how are we measuring them? That's a great question. We're not limited, but they're based on user perception at this point. We've basically got a baseline measurement of where things perform on a normal day-to-day basis. Our biggest challenge from a performance perspective isn't the back-end environment. It's the connectivity to the environment, and that's, most of our problems that we face are based on the DSL or the cable connection going down. So what we've set up is some monitoring to understand that before and ahead of time. We've also communicated to each of the practices, geez, you should have redundant connections, and they say, that's a great idea, and then you tell them how much it costs, and they say, no, thank you, I don't need that until it goes down. But we've baselined our entire environment on the infrastructure side, and we measure against that. But really, the biggest challenge is the connectivity. That's where our performance gets typically degraded and where we have downtime. Not the best answer, but hopefully it covered what you're looking for. Was there a specific reason to use that many servers and that many VMs? Sure. Sure. Driven by the application vendor's requirements and limitations. So it was driven by that and driven by the amount of memory and processors that we could fit in a box and use in the previous version of VMware. Now that we're moving that forward, we're hoping to get better consolidation. That's our initial number before we've gone down the path of testing it and validating what we can put on. The challenge we're facing is our ability to add more resources to the server and utilize more resources on the physical box for each of the guest OSs. What we're also having happen at the same exact time is the application vendor's requirements have doubled as well for processors and memory. So the two have kind of butted heads against each other, where we're hoping to get better consolidation. The vendor requirements have changed, and it's kind of put a bit of a kink in that.
Moving to deep security 7.5 will help you there.
Absolutely.
The performance cost of security will go down. Yep, you would set it up so that the appliance will not be vMotioned off. It will stay on the host, and there's one per host. So wherever any of your other VMs are automatically vMotioned by DRS, the next appliance on that host will take care of securing that. So I guess it works with DRS.
Sure.
How does the network bandwidth affect when the definition pushed in during the business hours or the patches from the vendor during the business hours? Do you guys do some analysis on that?
So pattern updates are one of the most serious operations that typically impact user performance, because you will do your schedule scans commonly during your maintenance windows. So while that tends to bog down system resources significantly, it's an issue for organizations that require 24/7 uptime, and they don't want the system SLAs to be affected. So what commonly becomes your AV storm contributor is the pattern update problem, because often because of the threat evolution that we are in the type of market we are in, where the nature of threats is changing so rapidly, your AV vendor needs to send out pattern updates to all your agents multiple times a day, 3, 4, 5 times a day, which is anytime those patterns start getting pushed out with the existing market solutions, whoever the vendor is, there is no other way out but to have to ensure, if you want to be protected, you have to let those patterns get updated. And the common security products in the market are not smart about knowing that they're even running in a virtual environment, so they don't have any way of interfering and ensuring that those pattern updates are not happening in a contentious manner. So with the typical solutions, uptime, especially during regular hours, as you were talking about, will be an issue with pattern updates. With the case of this type of technology that we're leveraging, it's agentless, so the pattern only needs to go to the appliance, and even that pattern, as I touched on, is a much lighter pattern, because Trend Micro has the secret sauce called the Smart Protection Network, and the entire pattern does not need to be downloaded to, in our case, the appliance. So it's a much lighter pattern that's downloaded, because the real bulk of the pattern information is deployed and stored in the cloud. It can be in the public cloud, where a query is made from the appliance to your cloud, to the cloud, or it can be a local cloud server where the patterns are resident, and that's serving out the patterns to the different appliances. So the footprint in terms of patterns is much, much lighter with this type of model.
Anyone else? No? Thank you. Thank you all very much.